Think about this. You are tasked with sorting through an entire city's worth of mail, but you're not doing it alone. You have got hundreds of people working with you, each handling different parts of the process. Some are sorting by address, others are categorizing by urgency, and a few are even building new storage systems as they go. While it sounds chaotic at first, this team efforts turn into an incredibly efficient operation where every piece of mail gets into the right place without delay. This is the idea behind MapReduce, a system that turns the chaos of huge data sets into something manageable and organized. It's a way to break down massive tasks into smaller, more manageable pieces and process them across many machines at the same time. Today, we will explore how this powerful tool makes working with vast amounts of data not only possible, but incredibly efficient. So in this video, we will cover what MapReduce is and why it is needed at the first place. We'll also see how the map and reduce phases work in depth, real-world MapReduce examples like counting words in documents, the importance of shuffling and grouping data, how MapReduce handles failure and ensures efficiency. And by the end of this video, you will not only understand MapReduce, but also how it's used in real-world applications for handling massive data. But before we dive in, here's a quick quiz question to get you started. The question is, what's the most challenging part of processing huge data sets across many machines? Your options are dividing the data into manageable chunks, shuffling and grouping the data, ensuring data consistency and reliability. Let me know your answers in the comment section below, and let's find out how MapReduce addresses all of these challenges. Also, if you're interested to supercharge your career in data analytics, then the Professional Certificate Program in Data Analytics and Generative AI by ENICET Academy IIT Guwahati is the perfect choice for you. This 11-month live online course offers interactive masterclasses by IIT Guwahati faculty and industry experts, combining cutting-edge tools like Generative AI, ChatGPT, Python, Tableau, and SQL. You will experience hands-on learning with real-world projects and immerse yourself in the campus environment with a special session at IIT Guwahati. Plus, you will earn an executive alumni status from IIT Guwahati and IBM recognized certifications to stand out in the job market. And with practical training, career assistance, and a curriculum tailored to today's industry needs, this program is your pathway to become a data analytics and AI expert. So hurry up and enroll now, and you can find the course link below. So first, let's start by understanding what is MapReduce and why was it created. In simple terms, MapReduce is a programming model that allows you to process large data sets across many machines in parallel. But then, why was it created in the first place? Back in early 2000s, Google was collecting massive amounts of data about everything, from people to systems to processes. This created an enormous problem. That is, how could they process this data efficiently without overwhelming a single machine? Vertical scaling wasn't enough anymore. Google had to horizontally scale by using hundreds or thousands of machines. But processing across so many machines could be tricky, especially when you're dealing with failures or data consistency. And that's where MapReduce came in. It was designed to break down the task into smaller chunks and process them in parallel across many machines. Now, it helps solve problems like failure recovery, data replication, and efficient data processing. Let's look at an analogy. Think of MapReduce like organizing a massive garage sale with many sellers. Now, if you have one person, which is machine, running the whole show, they will be overwhelmed by the volume. Now, instead, you can assign each seller a small section of the garage. They organize their items, but at the end of the day, you need to collect all the data from their sales and combine it efficiently into one final report. MapReduce is that method of organizing, collecting, and summarizing the data smoothly. So now that we know what MapReduce is and why was it created, let's dive into how it actually works, starting with the map phase. Map phase means splitting and mapping data. Now, the first phase of MapReduce is called the map phase. Here, the large data sets are split into smaller chunks. Each chunk is processed independently and the data is transformed into key value pairs. For example, in a word count program, each word becomes a key and its occurrence becomes the value. Now imagine you have a set of documents. Instead of one person reading every document, you can assign different workers, machines, to read each document and count the occurrence of each word. Here, each worker then creates key value pairs for the word it finds. These key values are like the worker's individual tally of the items. Let's say you were trying to organize a team building event with 10 participants. You assign each person tasks like collecting specific items for the event, like water bottles or tents. Once everyone finishes their part, you can count how many times each item was collected. MapReduce is this way. Each machine works on its own chunk of data and creates key value pairs like apple 1 and banana 1. And once the data is mapped, we move on to the next critical phase, which is called shuffling. Let's talk about the shuffle phase. This usually means grouping the data. Here, the key value pairs are reorganized based on their keys. For example, all the instances of apple get grouped together, all instances of banana get grouped together, and so on. This is an important phase because it sets up the data for the reduce phase. If the data wasn't grouped correctly, it would be impossible to add up the occurrences for each word. Think of it like separating your items from the event into categories like water bottle, tents, and so on, so that you can count them properly later. Imagine a classroom project where each student has collected different parts of a larger project. Now, before assembling it, you need to group similar parts together. Example, all the reports go together and all the pictures go together. And that's the shuffle phase in MapReduce, grouping data before the final assembly. So now that we have shuffled the data, we can finally move on to our next final step, which is reducing. Reduce phase combining data. In the final reduce phase, the group data is processed to generate the final output. The goal is to combine the values associated with the same key. Now, using the word count example, we would add up the counts for apple and banana. So if the apple appeared 2 times in the first document and then 3 times in the second document, the final count for apple would be 5. This is where the data from multiple workers come together to form the final result. You can think of this phase like assembling a report for your event. After you have collected all the data from each item member, you now summarize and add the totals together, like counting how many total water bottle and tents were collected in total. Now, with these concepts in mind, let's look at how MapReduce handles a real-world data set and sees everything we learned come together. Let's apply everything we have learned using this scenario. So this is the word count example. So here we've got 2 documents. Document 1, this is an apple. The second document is apple is red. Let's talk about the map phase. In map phase, each document is processed, turning words into the key value pairs, which is this, 1, is, 1, and 1, apple 1 for document 1. And then apple, 1 key value pair. Next is, 1. Next, red, 1. This is for document 2. Next, we talk about the shuffle phase. Now that we group all the occurrence of the same word together, which is apple, bracket 1, 1, is 1, 1, red 1, this 1 and 1. Next, we've got the reduce phase. Finally, we will reduce the values by summing the counts. Apple 2 is 2, red 1, this 1 and 1. The final result gives us the word counts for the data set. Now, let's talk about how MapReduce handles failures. MapReduce has another powerful feature, failure recovery. In a distributed system with hundreds or thousands of machines, failures are bound to happen. So how does MapReduce ensure data consistency? Now, if a map or reduce step fails, the system retries the operation. This retry happens because MapReduce functions are designed to be idempotent, which means the result doesn't change if the operation is run multiple times. This ensures that if there's a failure, the system picks up where it left off without disrupting the overall process. To wrap it up, MapReduce is an incredibly powerful tool for handling large data sets across multiple machines. By breaking the task into smaller chunks, which is map, organizing them, shuffle, and combining them into a final result, reduce, MapReduce makes it possible to process vast amount of data efficiently and reliably. This model has become the foundation for systems like Hadoop, which is widely used today for big data processing. So guys, that's a wrap up on this video. If you like this video, do hit the notification bell and subscribe for more such content by Simplilearn. Till then, thank you and keep learning.